Let's do a second example for solving systems using substitution. Let's say, what if you actually don't have an isolated variable to begin with? So here we go. Our equations are negative 5x minus y equals 12, and 3x minus 5y equals 4. So the first thing that I need to do in order to solve this is I need to isolate either x or y in either equation. As I look at the first equation, there is a y all by itself here, meaning it doesn't have, it has a coefficient of 1, meaning it has a coefficient of 1. So that's going to be the easiest thing for me to isolate. So I'm going to start by taking this equation, this first equation, and I'm going to move the 5x. So if I move the 5x to the other side, that means it becomes a positive 5x plus 12. Then I need to have a positive y, not a negative y. So I'm going to divide by negative 1 everywhere. And I get this new equation, y equals negative 5x minus 12. So now I have an equation where y is isolated, and now I can substitute. This information can be substituted in for y in my second equation. So let's do that. 3x minus 5, and then instead of writing y, I'll write negative 5x minus 12. And all of that's going to be equal to 4. Now, recall, this is just the equation that was above, but instead of y, I have substituted. So here I need to distribute and combine like terms, and I'm going to make sure that I'm careful with my signs, because in the middle here, when I'm multiplying by negative 5, I have to make sure that that sign gets distributed. So we'll have 3x plus 25x plus 60 equals 4. I'm going to combine like terms and subtract the 60. So if I subtract 60 from both sides, I'll get negative 56. And when I combine like terms, I get positive 28x. Now let's divide by 28. And x is equal to negative 2. Remember that this is a system of equations, so the solution is only halfway done. The rest of the equation, the rest of the solution is going to come when I take x and I plug it back into one of my original equations. Or I can even plug it into the equation that I rearranged, which is what I'm going to do. So I take this equation here, y equals negative 5, and instead of x, I'm going to substitute in a negative 2, and then minus 12. So y equals positive 10 minus 12, or y equals negative 2, and I finalize my answer by putting it in a coordinate pair. Okay, that was our second example.